Hi, everyone. Welcome to this webinar interview. So in the spirit of rising tide raises all boats, I've gotten in my head to have this mission to really promote and help advertise some other people that are doing really good things in the industry that I'm in at avoidingmold.com, which is water damage. And I do the mold piece, but there's other people doing the water damage piece. Yeah, from solutions to products. And so with me today is someone who I would like to call my friend, Bob Kelly. I've known him for a very long time, back from my days in Chicago. I actually don't know how long we've known each other or where we met exactly, but it's been a blessing in my life. I've been on at least one of his jobs that was fascinating, but he's an inventor, he's a contractor, he's really a thought leader, I think, in terms of moisture management. And so I would like to introduce Bob Kelly, and I'm going to ask him to further explain and all the hats that he wears, because this is a complicated space in buildings and water damage, as you know. And we do have to wear a lot of hats and be thinking outside the box. And Bob epitomizes thinking outside the box. So Bob, thanks for being here.
Wow, you're very kind, Cheryl. Thank you so much. You know, I have a hard time describing what we do for a living, because it's like, we've gotten into the space of like water management and controlling or managing, like vapor and, trying to get water out of masonry structures, which just seems to have eluded the industry ever since masonry structures have been built, really. So to back up a little bit, you asked.
So I said roofs. I didn't mention that masonry was one of your specialties. So maybe we can just go over. So what are your specialties?
Well, originally my love was restoring old Victorians. So what we used to do would be we put the foundation in, build the addition. After all the mechanicals went in, we would copy the millwork, grind the knife, do the cabinets, solder the copper gutters. And so the people that I worked for, they were true craftsmen, and I just didn't know any different. I thought this is normal. So so when I was lucky enough that after only 3 years of being in full time in the trade, but for 4 years before that, I was sanding cabinet doors in my brother's cabinet shop, demoing all these old houses, and just doing all the grunt work. And when I came out of school, I didn't realize I actually knew something. And so I went to work I studied psychology.
What a good fit. Actually, I wish I studied psychology or medicine or something. Well, that's interesting. Fun fact.
Well, there's a lot of people with PTSD with water issues, but that's a whole nother conversation.
Absolutely.
Yeah, I joke with my clients that they're at stage 5 when they sign a contract. Full acceptance. Anyways, I don't mean to digress, but I guess
Victorians to somehow we end up with masonry roofs. You're doing millwork and fine interiors, and
now shifting to roofing. So what happened was, it's like, so making a living on doing really nice interiors, like the last, I call it my last nice trim job, was a $500,000 ebony inlaid staircase that had all kinds of woods in it. It was gorgeous, but then that was when the bottom fell out in 2008, and a friend of mine said, this work is gone, just forget about it. He said, but he was a home inspector, and so he said, but there's a lot of these split face block buildings out there that need a bunch of guys crawling all over them, sealing them up. So as time went on, now the referrals that we started getting were related to rotten sheathing, some bad flashing details, doors that leak, and at the same time, I had just rebuilt a 1885 house into an old-looking Victorian up in North Chicago, and there I had done a witch's hat, like an 1812 compound curving roof on the corner of a roof, and I needed curved copper valleys. And this guy came out as a side job, and it just blew my mind. He used tar paper, made the pattern, soldered everything in place, and I fell in love. My love affair with sheet metal began in '98.
Wow.
So we started getting these jobs that required more sheet metal, flashing details. We're just focusing on really leaks and flashing details. Well, the people who fabricate the metal for me, there's nothing they can't do. They're working on a CNC break. And so, like, I got this reputation with one fabrication shop that I would show up at 5 o'clock in the morning with a drawing, and they're like, "Oh, here's Kelly again." Oh my, what does he want now, right? But it was always the same thing. It was similar materials bent in a custom shape that was able to cap off something, cap it, and shed water. Well, I'll try to keep this short. It's kind of a long story. So at the same time, there was a building I was working on that they had a mold issue in the first floor of their nursery. So with everything gutted, we're like, well, let's see what happens when we throw water on the side of the building. Well, the spot of water that was this big on the outside, well, on the inside was this big and taller.
Whoa.
And so that begged the question as to how does this happen?
And tell me about this wall. So this was the split face block wall?
Split face block wall.
Okay, so can you just explain? So some of my audience are not in Chicago doing split face. That's like a concrete block, if I can say the layman's terms, a concrete block that you can use inside and outside, kind of a thing. It's structural, right? It's holding up the building.
It's structural.
But you don't need to put a siding on it.
You don't have to do a siding on it. Well, that's what the industry wanted you to believe. So they would take cinder block and they would crack it, creating texture when they separate these two chunks of block. And so they would use this as the building blocks for a 3-story building. And that's all they had. There was no siding on it. It was just this porous masonry. And when you split the face, you end up increasing the surface tension or the surface area of the block by like double. So of course you're going to get water, saturating it. But nobody really thought that masonry had that effect because it was just a fairly new application. So anyway, I asked the homeowners if I could just test the moisture in the trusses. If there was water coming in, then there's got to be some water, affecting the structure. I was just curious. So I made some probes. I drilled holes through the quarter round, and I was tagging trusses on all 6 units. And I was getting these moisture readings of like 40 to 65%.
In wood?
In wood, under the flashing.
Wow.
Right. Okay. So this is like 14 years ago.
Yeah.
So
for everybody out there, 40 to 60% is fully saturated. Like all the cells are full in the wood.
So I didn't understand the concept of moisture movement. So, but I knew that if we sealed the outside was sealed and the inside was sealed with drywall, well, where's the water? Maybe the water goes up, who knows? So we made like an oversized coping to go on top of the parapet wall. She wanted to change the color of the metal. So I made it oversized my theory was it's got to come up the top. So the next year, the friend of mine who he referred a lot of work to me. He was a home inspector. He pulled a stone off the top of another house near Wrigley Field and got a blast of hot, wet air in his face. And it was middle of summer. And he said, I think we need that thing you did last year at this house. So we went around to some roofing supply places and we cobbled together a hollow support for stones so that air was able to blow through. And then we did the same thing by separating the roof membrane from the parapet wall and then capped it off with sheet metal. So it created an umbrella of sorts.
And a bit of a chimney, like almost a vent, huh?
Exactly. So you turn the whole building into a linear chimney. So the guy that we were working for, turns out he's the head of Parkinson's research at Northwestern, even to this day. And we're like, we don't know what to do, but this is better than what's available on the market. There's nothing available to fix his problem. So he said, okay, well, I gave him a price, seemed steep because it was a lot of work. And then the end result was the mold smell left his house.
So did you remove any drywall in this situation, or was it So we don't
No,
really know, but he felt good.
he felt good. He couldn't smell it anymore.
Mm-hmm.
So then somebody else caught wind of that process. And on the next building we did, it was a 6-unit building in downtown Chicago. We did the same thing, took the capstones off, put a metal coping on that had 2 layers that was able to breathe.
Mm-hmm.
And a really unusual thing happened was that on a dry afternoon, the entire side of the parapet wall from the roof system to the top of the wall was completely wet. And we had no idea why that happened. Well, now we know that when we relieve the pressure of whatever's sealing the top of the wall, there's a rush of water to the roof. And I don't quite know what it is. It's something that has to do with barometric pressure, but there's a lot of vapor pressure in these buildings that the stands accounted for. So anyway, sorry, I'll try to keep this shorter. So we just kept on getting one building after another. And we did one year, one another year, 2 the next year, 10 the following year, 20 the following year. After that, we started getting the same results, and then designing these vented flashings and venting the roofs. And so at some point we started to repeat our profiles. And when we repeated the profiles for different applications, but all the same theme, like, we've got a product line.
The inventor.
The inventor, right.
Inventor hat title.
So anyway, that's kind of how we got started in doing this. And then the more we played around with designs, the more confident we became in trying new things. And anyway, so that's kind of how we got started.
Okay, so it started with a parapet wall and masonry. Just so I mean, I get a lot of people who think flat roofs are flat. And I'm always trying to, so fun fact here also that flat roofs slope somewhere. Where do all these flat roofs slope in these houses that you're doing that are basically like a 3 flat or a 6 flat? So they're 3 units, and then they have a parapet, which is disguising the flat roof that actually slopes somewhere.
Right.
And so when you see damage there, you're seeing the damage where? In the wood framing of the roof, right?
Right. And at the perimeter.
At the perimeter.
At the perimeter at all these buildings, because so the buildings, all the roofs have a 1/4 inch per foot pitch. So imagine.
Oh, it kind of goes off the back. Isn't that what a lot of these do?
Well, the old ones go off the back. So you've got like a shed roof that goes from front to back. But on most of these, the newer ones, they all go to the side, because the way the plumbing is set up coming out of the house, the storm lines in Chicago tie in with the sewer line, so that the sewer line is always on the side of the building. So that's why they call them, the gutters are called scupper boxes. So in an 80-foot long building, there might be 3 boxes that collect the water off to the side and then tie into the storm line, go out to the street.
So it's basically a gutter, a downspout coming off a scupper box.
Correct.
Yeah, I've talked about that in some of my videos. All right, but I know you also do things with sloped roofs. And so how did you get from, so now you're doing these flat roofs, you have tons of work, but then you have other things. Well, you have other products I know, because I've had some clients that have consulted with you and and I know we've had conversations about venting these really complicated roofs that I usually suggest people don't do. And why shouldn't they do them? They don't vent, right?
Right, they don't vent, right.
In comes Bob Kelly. So another situation that doesn't vent. So how did that transition happen from doing these venting the parapet walls to then you have other venting products? And I don't know if you have other ones, you can tell me.
Well, we've got a few for pitched roofs. So we found that, okay, so let me back up a little bit. So I was working on a job, we were doing 2-piece metal coping where the metal is perforated on the bottom and creates a 1/2 inch gap. And then we have a cover on top. And that was the finished product. So I was looking for a hollow rigid extrusion, and I kicked over a yard sign. The yard sign, right? That's the magic sauce, corrugated plastic. It's hollow. You can layer it up. It's thin enough so that bugs can't really get into it, and it supports the weight of heavy stones. So So that's how we've managed to learn how to vent these buildings. And we use foundation drainage mat and also corrugated plastic. So that in pitched roofs, we take the same corrugated plastics, and we've been making a vent that caps off over the fascia, but lines up with the sheathing on the roof system. Then the gutter goes up against that corrugated plastic, ice and water sealing in a gutter. And so that's how we're able to get continuous eave venting. But in
but
all the
not
cut up,
through a soffit, or there isn't even an overhang.
I don't even look at soffits anymore for soffit venting. My soffit venting is actually the leading edge of where the plywood and the fascia come together, because that's the furthest point of a roof. And that's why we discovered that if there's a thin opening, linear opening at the very end, and there's a fatter opening at the ridge, that in the world of fluid dynamics, it creates almost like a garden hose effect of air and rushing past the plywood, and it dries off the plywood. So
I like that idea. Plus it probably looks pretty good because you would have like a black line then. Almost
just
like
a really beautiful black shadow line that's only 3/8 of an inch thick. So when you get into those more complicated framing issues, the way we've learned how to compensate for it is use the corrugated plastic, but you have to build it into the roof system before you put the sheathing on, because the air can come up to the valley or the hip rafters, because that's where if you've ever heard the term a dead valley, it's because air can't circulate, and that's why things go bad. But we learned that if we separate, you don't need, I mean, all you really need is a 1/4 inch of airspace. I know the codes say like, 1.5 inches, and it don't create any difference in size from the top to the bottom, but we found that you need very little airspace to vent the roof the way we're doing it. So what we did is we separate the sheathing from the valley rafters. And when the air comes into that space, then it travels up the valley rafter to the ridge vent. And that's how we've managed to get these complicated roofs to vent, to create a cold roof.
Wow. So is that in the valley and also in like the ridge, when you have like a clipped gables, those kind of things where there's all these, it's like up, it's up and down, W kind of shapes up and down on the roof.
Exactly.
Do you do it in both places?
All the places. Yeah. Now I don't make a ridge vent because there are so many ridge vents out there, but we do modify it because the ridge vent companies want you to hold your ridge vent back one shingle from the very end. But the very end is where all the hip and valleys come together. So what we do is we extend that valley, or extend that ridge vent past that point of where everything comes together, and then cap it off with sheet metal. So we've had to make modifications on manufacturer's instructions, which sometimes you gotta do what you gotta do.
Wow. And then I know there's something else really interesting that you do that because I think it's interesting, is that you're working on roofs, and I get all these people, especially remediators, who are working on or people that are trying to remediate their moldy attics or their moldy roof trusses or whatever. And I know you see a lot of these, and they're always like, well, we can't remove any of these. But I know that there are ways to remove them. And then the issue is, so if you could talk a little bit about how you do that. And I know there's a tent involved in this, which I think is very cool. And but number one being that there are structural elements that yes, the remediators shouldn't remove it, but people who are qualified to design and be constructing structural pieces or be amending the structure can, because it could be rotting, and so the solution isn't to paint it with a coating. So can you talk a little bit about that piece of what you do? Because I think for people that follow me that have all this damage that's gone on for a long time unseen, I know you see it. What are your solutions?
Okay, so the cause of the problem is that traditional masonry and framing is to have the masonry support the framing. So that's been going on for thousands of years. So what's happened, just a 2-minute history, is that our materials have gotten a lot harder, which allows in masonry allows water to pass through quicker. And at the same time, our wood supply is depleting. So we don't have the old growth lumber of the trees that are 5 feet in diameter anymore that have super high resin content and all the growth rings that hold all the resin that keeps it from rotting. Now we're using tree farm lumber, which you stick that in a wet substrate, it's going to suck up the water and go bad. And all the particle boards that are also used in framing. So, you know, I mean, as a father and, you know, supporter of my family, you know, I'm trying to find some places where there's a lot of ongoing work, right? So we find that to create value, you know, most guys are taking the trusses out of the buildings, which removes the drywall, the low voltage, the HVAC, and the insulation. I mean, just that demolition alone and reconstruction is probably $250,000. But we find that if we can just repair the ends of the trusses, then, you know, we can save our clients a lot more money and create value, making money for us. So the first time we did this, we found, you know, actually I did some test cuts in the roof and found that my test cuts showed me healthy, like the only healthy trusses in the whole building. When we went ahead and did the roof tear off, I found that all the other trusses were bad. So we were in a little bit of a pickle. We had to cover the place up pretty quickly, and especially it was in the fall. So I called a friend of mine who owns a marina in Michigan. I'd been thinking about a tent, and he looks at me like I've got 3 heads, you know. So he said, look, I've got this boat shrink wrap. So we made a frame out of PVC pipe and then wrapped the whole building in boat shrink wrap, made this tight closure. And we're able to work under it and then repair all the trusses and then do the roofing. And then when it was over, we were able to take the tent down and call it a finished product. We were able, because when we do these tents, we're exposing, well, they're up for 3 to 4 months at a time.
Oh, and how do they not rip to shreds? Because I will say, I have a quick story that there was a high-end house in my neighborhood, and it was like a Friday in June. They're finishing up at 3, blue skies. They left and they had ripped off the roof. You're always like, oh no, they ripped off the roof and they put on a tarp, like a blue tarp. And they had that thing battened down all over. And I was like, wow, they're really working hard because they know they're not coming back on Sunday. They weren't gone an hour when the weather changed. A big wind came, which brought in even more wind, and the sky grew black. And then it just, the wind, between the wind and the rain and the pressure differentials, it just ripped that thing to shreds.
Oh,
how does
I can feel it.
Well, I mean, I was driving by, I had to call that. I called them. I knew who, because the owner's not living in there. And you just could see the storm coming. And yeah, and they tried so hard. I felt so bad for them. But so what's the solution? So how do you not have that happen?
So we use 10 mil boat shrink wrap, and we put an exhaust fan at one end of the gable. We changed from using plastic PVC pipes for the tenting frame to now we have aluminum rafters that are really, really durable. So what we do is when we wrap the boat shrink wrap around the ends of the rafters and then tuck it into the wall and secure it. And we do that on both ends as well as the sides. So when we shrink it down, the strength of that shrink wrap, it's an amazing clamp. You know, it's a 20-foot wide by 70-foot long structure that, you know, has got about 8 to 10 feet up to the ridge. And when we shrink wrap this whole thing, we've been at 60-mile-an-hour wind gusts, and it stayed. And then with the fan running, then it keeps a nice tension on it creates negative pressure inside the tent so that the plastic doesn't bounce around all the time.
Yeah, I think that's the key, is that but they didn't have, it's like on a tent, they have a rainfly and there's an opening at the top. They needed to actually have some holes so that the air could move through it. And so you're providing that mechanically, where there is some places where, yep, come on in and go on out, you know?
Exactly. Right. Now we've been in some, you know, very stressful moments. So when I converted from using PVC pipe to aluminum rafters, we had a tent up. It was kind of an early winter, right? and the weather was great, like you were saying, but overnight in came a extremely heavy, wet snowstorm. And I was up in this roof until probably 2 or 3 in the morning. And when I came back the next day, the whole thing had collapsed on top of the house. Now, it's okay. Anybody who's my client, you're in good shape. Okay. It's okay. But the shrink wrap was so strong that it didn't puncture in this case.
Well, I
And
have to
there's
say,
about-
I don't see boats like with the, you see them with their canvas cover ripped to shreds, but you don't see that, they're going down the highway at 60, 70 miles an hour with the sailboat shrink wrapped, and it's not ripped to shreds. So, and the other place I've seen that, I don't know if you know this or if there's a relationship, is that when I've been in Europe, I saw this a lot on facade work. So they have these older buildings, and they would basically, to work on the outside where they're either, your kind of stuff with masonry, tuck pointing or sandblasting or whatever they're doing, that they kind of cordon off the sidewalk, and they're working above the sidewalk, and they're basically shrink wrapped in the scaffolding on the side of the building.
It's a great application. It really is cool.
Well, that's really cool. But I love what you're doing, because I get people all the time asking me, how do we keep the building dry while it's under construction? Because it's like in some climates where it's raining a lot, we're getting some problems with the lumber anyway, and it's a struggle for contractors to keep on a schedule when supplies aren't always available, and then the thing is getting drenched.
Well, what we're doing with the trusses, after we set up the tent, is that we cut back the plywood, usually about 4 feet on both sides of the roof system, so that we can see exactly what the condition of the trusses is. So, for example, when we do a project, do a roof tear off with the intention of introducing venting, we cut about a 1 foot slot or 1 feet of plywood off of the roof. So that way we have a direct examination of every single truss, because, come on, almost every single building that's, within 30 years old has this quick growth lumber. So if we can go through and, that's my green flag to say, go ahead and finish the roofing project. But if we, so if there are rotten trusses, what we do is we pack out the ends of the trusses with solid blocking and plywood on both sides of the truss. And then we make 1/4 inch thick metal brackets that bolt up against the inside of the CMU wall. And then there's enough holes that we drill into the sides of the brackets so that we can get high tensile screws in to support the truss. So we rehang the truss off the inside of the building and cut it away from the support in the masonry. So that's how we've been dealing with that.
You should. Do you have pictures of this on your website?
I do. Yeah, I do.
Yeah. It's really fascinating to me, because that's like the worst thing, is when a structural element is going bad. And talking about expensive, and then in the roof, it's exposed to the weather. And it sounds like are hitting a home run on, you got this part, you got this part, you got that part. And I think that's but I think that's really hopeful for people that are struggling with their buildings, being, challenged and compromised. I do want to point out to people that we're talking about decay a lot is what Bob's seeing, but before that came mold, I'm sure. And I don't know if you see your clients being sick at all. Is that something that you've experienced? Well,
because of your help and your exposure to me, as now I'm starting to understand. I used to blow off mold, honestly. It's whatever, just wipe it off. I'm not singing that tune anymore. I'm seeing too many people. I'm starting to see the signs of how people are behaving after being exposed to mold. And the closest thing that I can describe is I had a sister who had chemotherapy, and the effect of mold on the brain I see it as being fairly similar to people who have chemotherapy. And chemo brain. Chemo brain. It's and then the couple they referred me to in Detroit, she studied this so much, and she was using did I tell you how she was using a Fitbit to study her heart rate? Because when she was exposed to mold, her heart would go up before she felt the symptoms of the mold making her sick. So I've got a completely different attitude about this. So I'm thank you very much, by the way.
Oh, well, good. Well, thank you for sharing that, because I think there's so many people, there are a lot of people out there that, because the symptoms they're kind of sometimes benign, and we don't realize that they're accumulating, or we don't realize that things like mold rage or mood swings, which is what you're talking about, or I can't think straight, I've seen your moments all of a sudden. So it is, my research is, mold is a neurotoxin. It's gonna, and I mean, there's people who say it only affects certain people. I think over time it can affect anybody. It's just a matter of how long do you have, and how well does your body detox before your bucket's going to overflow. And then there's going to be something else that's going to be like, oh, it's Alzheimer's, Parkinson's. I don't even know if maybe cancer, but all these things where you start to say, well, I don't know what caused that. That's what the world would say. We don't really know what causes it. Well, there are some things that maybe could be related. I'm just throwing it out there. So, so you have this company that's WickRight that you use, that you're doing your inventions, and are you doing contracting still?
Oh yeah, every
work
day
on the job site for these projects.
Right. So I mean, luckily, what's really great about discovering this kind of work is it's the only repeatable work that I've ever found, that custom work that I've ever found. And so, because in order to, be a successful businessman, I mean, I like the variety. I can't not have variety, but it's a replicable skill that when my guys come in to do capstone flashing or roof venting or basic roofing, they know what to do and I don't have to be there. So I've been able to grow the business. Not much, just, I mean, I've got 6 guys who are just wonderful, hardworking gentlemen. And I can spend more time promoting what we're doing, bidding jobs. But there's a sweet spot between having too many people. So I like to fly under the radar of, 6 or 7 people. It's a great number. But, but the kinds of jobs that we're taking on mostly is like, basic door pan flashing. We take out doors, flash under capstones, flash under limestone sills. We do complete roof tear-offs. We seal the outsides of buildings. And what's interesting is that in the process of doing all this work, we're starting to debunk a lot of tradition that's being used in masonry and roofing. And that's where we're starting to get known for. I mean, the results on the street are a lot different than that from a desk. Yeah.
And unfortunately, we have to wait 20, 30 years, 10, 15, 20, 30 years before we get to find out. And then I think the process of that message getting out is challenging. So you're in Chicago, I believe, or in the Chicago area. Do you travel? Yeah. So I have people watching this from all over the country and even the world. And they're probably wondering, like, is there one of these in my town? Is there a Bob Kelly where I live? And what do you say to that?
I travel. I like getting out of Chicago and, and teaching other contractors our techniques. In fact, I've got a project coming up in Colorado. A roofing contractor who does his own sheet metal work found moisture under the flashing at a waste treatment plant or water treatment plant. And the manager said, look, this is a brand new facility. We cannot have any mold here. So I'm going to go out there and bring the materials and show them how to install.
But then do you bring your whole crew, or are you, how do you do this?
No, it's just me.
Jack of all trades and a master of all of them.
Well,
you're a unique species, and it's my pleasure to know you and to watch what you're doing. So I think we get to the end here. I think you've done a great job of describing what you do. How can people? What's your your website? How can people get a hold of you or look at your products? Because you sell your products to other builders too, right?
Yeah, yes, we do. So they can find us on the web. The companies are WickRight.com or WickRight General Contracting. And so on WickRight.com, there's a full catalog of the drawing of all the like parapet wall profiles there's 12 different profiles and the materials that we use to treat those. But there's a lot of other stuff that comes along with all these jobs. There's, we don't have anything in the website about reinforcing all the framing, but that's actually, for me, that's more fun than roofing. I like the heavy structure. And then But it's a good place to start. But every problem can be solved.
Mhm.
That's the bottom line. And if it's going there with a good attitude, you'll find a way to solve it. Just got to think outside the box sometimes, and I can't get enough of this stuff.
Yeah, and we come first full circle because I described you as a think outside the box guy, and I do think that the world we're facing with, we've tightened up our buildings. Sustainability is a good thing, but then we have we're using all these new materials in new ways, and we're finding out things we didn't know until it, 10, years down the road, and it's great to have people like you working on this stuff. So it's my pleasure to have you with me. So WickRight.com. Is there any final thoughts or insights that you would like to share with our audience today? Do you have upcoming events? Anything that we should know about?
Okay. So as far as like any insights, I would say, and not being negative, but don't trust your contractor or architect. No offense. I know
I agree. I mean,
here's the problem, right?
Always think for yourself.
Do your research and think for yourself and get a lot of opinions, because see, the issue that we're in, it's a really tough situation because architects have a very difficult time getting field experience from where their point of view has to remain. They don't have enough time to really kind of go outside their shell. I mean, it's legitimate to say that. Mm-hmm. So they're stuck reading the guarantees from the manufacturing companies, but the confluence of all these different materials, like for example, foam insulation on the inside of your cinder block or any kind of masonry structure. One thing is a lot of people say, oh, foam it, keep the water out, keep the water out. The problem is that you end up creating a whole wall of water that cannot dry out, which exacerbates the wetting and the rotting effect of your timbers. So just get a second and third opinion, because everybody's kind of throwing darts and throwing spitballs against the wall, and a lot of guessing going out there. And so, but then so that's the main thing. As far as like any upcoming events, we have a talk. I was invited to talk at the Building Enclosure Conference in Iowa, coming up on March 1st. And, I'm really honored to be part of the, 4 people who are, other 3 people that are talking. And, so bringing this point of view and the field experience to, building enclosure, officials, architects and engineers, it's really quite an honor to be recognized. So, well,
you're fascinating. I love listening to you. You just even touched on things that we could do this again and talk about spray foam, and we could talk about other things masonry related. There's so many things we could talk about. So there hopefully will be a next time. But for right now, people can find you at this conference in Iowa. What's the dates of that?
March 1st at the BEC Iowa Building Enclosure Conference.
Okay, and that's 2023. I think this video is going to be probably going out there for a long time, and hopefully it will bring more awareness to what you're doing and the good things that you're doing, and more awareness for all of us who struggle with mold and water damage, me included, to know that, it takes a team. We have to think outside the box. We have to rethink things conventional wisdom, that things we thought were true that maybe aren't true, and question, and be open to maybe we have to pivot and do something else.
Well, there's one last plug I'd like to stick in, and I want to thank you for your diligence and your devotion to this topic, because it cuts to the core of so many different things that nobody knows to even ask the questions. So thank you.
Oh, well, thank you. So everybody, I'm at avoidingmold.com. Bob is at WickRight.com. Thank you for being here, and don't forget to like and subscribe, and I'll see you in the next video.
Thank you, Cheryl.